Happy morning, students. Welcome back to physics online class. Last week you are all written online exam, is it? How did you write? Okay. Today we are going to learn the new lesson, Unit 3, Thermal Physics. This thermal physics, it is a branch of physics, and also mainly it deals with the study of heat and temperature. The word thermal, it is related to heat. The word thermal related to heat. So in this chapter we are going to learn some of the concept, that is heat and temperature, absolute scale of temperature, thermal energy and thermal equilibrium, expansion of substances due to heating, and also fundamental laws of gases, and distinguish between real gas, ideal gas, etc. First we are going to learn the concept, that is temperature. You all know that what do you mean by temperature? It is the degree of hotness or coldness of the object. Degree of hotness or coldness of the object. Okay. So we can check the body is hot or cool. Okay. By using this temperature scale. You all know that temperature is raised for the hotter object. If you are touching that hot object, we can feel the hotness. Okay. Why? What's the reason? The temperature of the hot body is raised. Okay. Comparing with the colder body. Okay. Colder body we can touch in your hand. So we can feel that the temperature is low for the colder body. And temperature, it is the scalar quantity. You all know that what is the scalar and vector quantity, is it? Temperature means only define how much heatness, okay, otherwise how much cold is there, okay. It can be mentioned with degrees Celsius or Fahrenheit or Kelvin, okay, how much amount of heat, 20 Kelvin or 30 degrees Celsius, okay, only it tells that with magnitude, okay, that amount of heat. So it is a scalar quantity, okay, only it represents the value, okay, how much amount of temperature is there. So it is a what quantity? Scalar quantity. And what is the SI unit of this temperature? Kelvin. Okay, what's the SI unit of temperature? Kelvin. Okay, the standard unit of temperature is Kelvin. And also some other units also there for this temperature, that is Celsius. Okay, degrees Celsius and also Fahrenheit. Okay, these are the other units of temperature. So what's the SI unit of temperature? Kelvin. What are the other units? Celsius and Fahrenheit. Now we are going to learn the property of temperature. What are the properties of temperature? See, we can define the body is in equilibrium or not with the surroundings. By using this temperature, we can say that body or system is equilibrium or not. What do you mean by equilibrium? See, it will be having the same temperature with the surroundings. Okay. So, for example, if you are taking that object temperature and the room temperature, it is same, means we can say the body is in equilibrium with the surroundings. And also, defines that kinetic energy of these molecules. See, if you are increasing the temperature, the energy of this molecule will be increases. That is, kinetic energy of this molecules is raised. Okay, kinetic energy of this molecule increases. So, the temperature increased means the kinetic energy of the molecules in the substance also it will be increases. And also, it tells the direction of this flow of heat. Okay, based on the temperature, we can say from which direction the flow of heat is transferred. Okay, from which object to which object. Okay, always the transfer of heat takes place from the hot object to the cold object. Okay, so direction of flow of heat also we can define by using this temperature. So these are the properties of temperature. We can find the body is in equilibrium or not with the surroundings, and the kinetic energy of this molecule is increased. If the temperature increases, kinetic energy also will be increased. and also it tells the direction of the flow of heat. Next we are going to learn the absolute scale or the Kelvin scale of temperature. What do you mean by this absolute scale? The absolute scale, it is also mentioned as the Kelvin scale. Okay, what is Kelvin scale of temperature? So listen here. See, so we can define that Kelvin scale of temperature. So this one, it is mentioned absolute 0. So here from the 0 is the referring point. So from this we can measure the positive temperature and also the negative temperature. For example, 10 Kelvin. So okay, this one plus 10 Kelvin, and similarly here if in this direction if you are measuring, we can get minus 10 Kelvin. Okay, so from based on this 0 we can mention this plus 10 Kelvin and minus 10 Kelvin. Okay, so this absolute 0 or the absolute scale of temperature, or it is also known as the thermodynamic temperature. Okay, it is also known as the thermodynamic temperature. See here, 1 degree Celsius, here it is equal to 1 Kelvin. Okay, 1 degree Celsius is equal to 1 Kelvin. Okay, so how will you define this thermodynamic temperature? So, if you want to define this thermodynamic temperature, before that we must know about triple point of water. Okay, what do you mean by this triple point of water? Okay, so a triple point of water means at one particular temperature and pressure, the 3 states of water will attain the equilibrium state. 3 states of water means at the 3 states of water. What are the 3 states of water? Solid state, liquid state and gaseous state. Okay. In these 3 states of water also will attain the equilibrium state at one particular temperature. What is that temperature? 273.16 Kelvin. Okay. In this temperature, the 3 states of water will attain equilibrium. Okay. So here some solid ice cubes are there, and here the liquid, and here the gases. Okay, this arrow mark represents solid will change to liquid, and liquid also will change to solid. Okay, here the gaseous state will directly change to solid, and the solid also will directly change to gaseous. Okay, and here the liquid will be changed to gas, and here gas also will be changed to what? Liquid state. Okay, so here in this 3 states, at one particular temperature, it will attain the same equilibrium state. Okay, the same temperature. What is that? 273.16. Okay, so here just you have to take this fraction of this, that is 1 by 273.16. Okay, it is the thermodynamic temperature of the triple point of water. Have you all understand what is triple point of water? Okay, what is the triple point of water? In these 3 states of water will attain the same equilibrium state at one particular temperature. Okay, that is the triple point of water. Okay, at what temperature will attains that equilibrium state? 273.16 Kelvin. Now, the each unit of the thermodynamic temperature can be defined as the fraction of 1 by 273.16 part of the thermodynamic temperature of triple point of water. Already I told what is triple point of water. See, the fraction of 1 by 273.16 part of the thermodynamic temperature of the triple point of water. That is the thermodynamic scale of temperature. Okay, how will you define the thermodynamic scale of temperature? It is defined as the fraction of 1 by 273.16 part of the thermodynamic temperature of the triple point of water. Okay, so that's the definition of the thermodynamic scale of temperature. So the temperature difference 1 degree Celsius is equal to 1 Kelvin. Okay, the temperature difference 1 degree Celsius is equal to 1 Kelvin. So 0 Kelvin represents the absolute scale of temperature of the body. 0 Kelvin is the absolute scale of temperature of the body. Okay, from this 0 Kelvin only we can measure that temperatures. Okay, so the 0 Kelvin is the absolute scale of temperature, and 1 degree Celsius is equal to 1 Kelvin, and the 0 degree Celsius is also equal to 273 Kelvin. Okay, 0 degrees Celsius represent 273 Kelvin. Okay, so the 0 Kelvin is the absolute scale of temperature. 0 Kelvin is the absolute scale of temperature. Now we can see the relation between the types of scale of temperature. Okay, different types of scales and their relation. First one, Kelvin and Celsius. Okay, Kelvin and Celsius scale. What is the relation? What is the related formula? Kelvin, K is equal to degree Celsius plus 273. Okay, this is the relative formula between Kelvin and Celsius scale. Okay, Kelvin is equal to C plus 273. Now is one example. How will you convert 20 degrees Celsius into Kelvin? See, by using this formula, we can change or convert the degree Celsius into Kelvin scale. Okay, and the Kelvin scale also we can change it into the degree Celsius. See this example, 20 degrees Celsius into Kelvin. Okay, so how will you write? Kelvin scale is equal to, instead of the C, what do you substitute? 20. Okay, 20 plus 273. Okay, so 20 plus 273. So it is equal to, so 20 plus 273, what is the answer? 293 Kelvin. Okay, no need to mention this degree sign for this Kelvin scale. Okay, so 20 degrees Celsius is equal to how much Kelvin? 293 Kelvin. Okay, 20 degrees Celsius is equal to how much Kelvin? 293 Kelvin. Just you have to add this 273. Okay, so this along with the Celsius scale, if you are adding this 273, we can get the Kelvin scale. Similarly, we can calculate that Kelvin scale into degree Celsius. For that, just you have to subtract this value. Okay, so we can change that into degree Celsius. Next, the relation between Fahrenheit and Kelvin. Okay, for that one formula is there. Kelvin is equal to Fahrenheit plus 460 into 5 by 9. This is the formula. Okay, just they will ask for one word questions. So please you have to be learn this formula. Okay, K is equal to F plus 460 into 5 by 9. Okay, so change the Fahrenheit into Kelvin scale. Okay, change the Fahrenheit into Kelvin scale. What's the relative formula? F plus 460 into 5 by 9. Next one we are going to learn about thermal equilibrium. What do you mean by thermal equilibrium? See, just to see this example, here one hot object is there, here the cold object is there. So you all know that the heat transfer from the hot object to cold object. Okay, when the two objects are making into contact, okay, just if you are making to contact the two object, the heat is transfer from the hot object to the cold object. Okay, heat transfer from the hot object to cold object. Okay, so this heat transfer takes place till that two objects also will attain the same temperature. The heat energy transfer until both of them will attain the same temperature. Okay, so that is the thermal equilibrium state. See here, transfer of heat from the hot body to cold body. Okay, thermal equilibrium, the main concept, the transfer of heat from the hot body to cold body until the thermal equilibrium is established. Okay, until the two bodies also will attain the same temperature. Till that time the heat will be transferred. Okay, from the hot object to the cold object, and both will attain the same temperature. Okay, now the two objects hot and cold also will attain the same temperature. Okay, now we can say the body is said to be in the thermal equilibrium. Thermal equilibrium means the temperature remains same. Okay, so the hot object to the cold object, the heat will be transferred. You all know, isn't it? Now the two systems are said to be in thermal equilibrium if the two objects also will attain the same temperature. Okay, if two bodies are said to be in equilibrium, then the two also will attain the same temperature. Okay, so the two objects are brought in contact with one another. Okay, transfer of heat energy from the hot body to the cold body until the thermal equilibrium is established. Okay, So in this thermal equilibrium state, what will happen? The hot object will lose their heat and the cold object will gain some heat. Okay, hot object lost their heat and the cold object gain some heat. Okay, so when a cold body is placed in contact with the hot body, some thermal energy is transferred from the hot body to the cold body. So as a result, there is some rise in the temperature of the cold body. Okay, so in this cold body, there is rise in temperature and the hot body will decrease in temperature. Okay, hot body will lose their temperature. Okay, this process will continue until these two bodies attain the same temperatures. Okay, this is called a thermal equilibrium. Okay, now you can learn the definition of thermal equilibrium. Two or more physical system or bodies are said to be in thermal equilibrium if there is no net flow of thermal energy between them. Okay, if the two objects will attain the same temperature, after that there will be no transfer of energy between them. Okay, that is called a thermal equilibrium. There is no net flow of thermal energy between them. Okay, that is the definition of thermal equilibrium. Next we are going to learn what do you mean by thermal energy. Just to see this example here, a cup of hot milk and a bottle of cold water. If you are placing on the table for some time, what will happen? You all know that, isn't it? The hot milk will attain the same room temperature. Okay, after some time, that is the hot milk will become cold and the cold water from the fridge. If you are taking just and if you are keeping on the table after 1 hour, just if you are checking the temperature, the cold water turns, otherwise it will be changed or it will attain the same room temperature. See here, the hotness of the milk decreases after some times. Why do you know? The heat is transferred from the cup to surroundings. Okay, heat transfer from the milk to the surroundings. Okay, so the hot milk turns to cold. Okay, after some time. Okay, similarly here this cold water becomes warmer after some time. Why do you know? The surrounding temperature. Okay, heat transfer from the surrounding to the cold water. Okay, from the surrounding to the heat is transferred to the cold water. So in the first case, the flow of energy from the cup of milk to the environment. Okay, the heat energy flows from the cup of milk to the environment. So the heatness or the temperature decreases here. The second case here, this cold water becomes warmer. Okay, the energy transfer from the environment to the water bottle. Okay, so this energy is termed as thermal energy. Okay, the energy is transferred from the hot milk to the surroundings and here the energy transfer from the surrounding to the cold water. Okay, so this is termed as thermal energy. Okay, this energy is called as the thermal energy. See here in this thermal energy, it is also known as heat energy. So in this heat energy, the process of heating is very important one. Okay, so what do you mean by heating? The process in which heat energy flows from a body at high temperature to body at low temperature. Okay, this one everybody know. Okay, the hot object, from the hot object to the energy transferred to the colder object. Okay, energy flows from a body at high temperature to the body at low temperature. This process of transformation of heat, it may be done in different ways. Okay, so the process of transfer of heat energy, it takes place in different ways. Okay, what are the methods are there to transfer the heat? Conduction, convection and radiation. Okay, what are the three methods are there for the heat transformation? Conduction, convection and radiation. Conduction, convection and radiation. Okay, conduction means you all know that. Okay, from the hot object it will be keep nearer to the colder object. Okay, with a direct physical contact the heat energy is transferred. Okay, that is conduction. Then convection. So here convection, by the actual movement of this molecule the heat will be transferred. If you are making the water to get boil. Okay, so here what will happen? If the water is started to boil, we can see the movement of the molecules. Okay, actual movement of this molecule takes place. Okay, so first when we are making to heat a bowl of water, first the bottommost portion it will be getting that heat. Okay, after that only the heat is entering into that top portion. Okay, so here the heat transfer from the bottom to the top by the actual movement of this molecule. For example, here convection process mainly takes place in the liquids and gases, but here this conduction process takes place in solids. Okay, then convection process takes place in liquids. Then what do you mean by radiation? Without any physical contact, the heat transfer from one place to another. Example, we all know that sun is our primary source of energy, isn't it? The sun, from the sun, the energy is transferred without any physical contact to the earth. Okay, that is the method of radiation. Okay, so like these three methods, the heat transfer from one place to another: conduction, convection, and radiation. The heat energy, like temperature, it is a scalar quantity. Heat energy is the scalar quantity. Heat is the scalar quantity, and this SI unit of this heat energy is joule. Okay, what's the SI unit of heat energy? Joule. It can be represented with the letter J. It is a scalar quantity. Temperature also scalar quantity. Heat also is a scalar quantity. What's the SI unit of temperature? Kelvin. What's the SI unit of heat? Joule. So like that heating process, cooling also process also takes place during this energy conversion. Okay, so here the process of transferring of heat energy, that is the body at low temperature is heated while the body at high temperature become cold. Okay, so this process is called as cooling. Okay, the body at high temperature become cool. Okay, so it lost their heat to the surroundings, so it will become cool. This process is called cooling. The process of transfer of heat energy, the body at low temperature is heated. Okay, so the hot cold object will become heat. Okay, and the body at high temperature will become cool. Okay, so here this process is called cooling. So during this energy transformation, heating process as well as the cooling process takes place. Okay, lower temperature object will gain the temperature and the high temperature object will lose their temperature. Okay, that process is called cooling. Next one important question, we are going to learn what are the characteristics feature of heat energy transfer. What are the characteristics of the heat energy transfer? The first point, always already you know, the heat always flows from a system of high temperature to low temperature. Okay, heat flows from the system of high temperature to low temperature. Okay, high temperature to low temperature, always the heat will flow. And during this heat energy transfer, the mass of a system is not changed. Okay, the mass of a system remains constant. Okay, before heating and after heating also, the mass of the system will become constant. The mass of the system not changed. Okay, during the process of heating as well as cooling, the mass of a system is not changed. Okay, that is next character. And during this exchange of heat, amount of heat gained by the cold body is equal to amount of heat lost by the hot object. Okay, heat gained is equal to heat loss. How much amount of heat energy is gained, that is equal to amount of heat energy lost. Okay, these are the three important feature or characteristics of the heat energy transfer. Okay, always the heat transfer or flows from the high temperature to the low temperature object, and during this process of heating or cooling, mass of the substance remains changed. Okay, the mass does not change. And the third one is during this exchange of heat, amount of heat gained is equal to amount of heat loss. How much amount of the heat gained by the cold body, that amount it will be equal to the heat lost by the hot body. Okay, so these are the three important characteristics of the transfer of heat. So next we are going to learn the units of the heat energy. Already you learned the SI unit of heat energy, that is joule. Okay, what are the other units of heat energy? Okay, the first one is calorie. Okay, calorie, it is one of the unit of heat energy. Okay, so the SI unit of heat is joule and this unit of heat energy, it is calorie and kilocalorie also there. Okay, calorie and kilocalorie. First we are going to learn this definition. What do you mean by calorie? See, calorie, it is defined as amount of heat energy required to rise the temperature of 1 degree Celsius in 1 gram of water. See here, we taken 1 gram of water. So in that 1 gram of water, we have to rise the temperature 1 degree Celsius. Okay. For example, first the water is 20 degrees Celsius. We have to increase the temperature 21 degree Celsius. Okay, 1 degree Celsius we have to increase. For that 1 degree increasing temperature, how much amount of energy is required? Okay, how much amount of heat energy we are giving? Okay, that is called as calorie. Okay, so now we can define calorie. It is defined as amount of heat energy required to rise the temperature of 1 gram of water through 1 degree Celsius. Okay, how much amount of temperature want to rise? 1 degree Celsius. For that, how much amount of heat energy is required? Okay, so how much amount of substance we have taken? 1 gram of water. In that 1 gram of water, we have to rise the temperature of 1 degree Celsius. For that, how much amount of the heat we have to give? That is called calorie. Okay, it is the unit of the heat energy. Okay, see the definition. Amount of heat energy required to rise the temperature of 1 gram of water through 1 degree Celsius. The next one is kilocalorie. Okay, calorie and kilocalorie, only one different only. Here we have taken 1 gram of water. So instead of this 1 gram, you have to take 1 kilogram of water. Okay, for that, how much amount of heat is required? That is kilocalorie. See here, 1 kilogram water is there. So in this 1 kilogram of water, we have to increase the temperature 1 degree. Okay, so first if you are taking the temperature, that is 25 degree Celsius maybe, we have to increase the temperature 26 degrees Celsius. For that, how much amount of heat energy we have to give? Okay, that is kilocalorie. So kilocalorie is defined as amount of heat energy required to rise the temperature of 1 kilogram of water through 1 degree Celsius. Here, instead of gram, we have to write kilogram. Okay, that is the only difference for calorie and kilocalorie. Okay, how you will understand this two definition? Very important for the 2-mark question. Okay, they will ask calorie or kilocalorie. Okay, calorie means here we have to mention 1 gram water. Here kilocalorie means want to mention 1 kilogram of water. Okay, so both also you have to rise the temperature how much? 1 degree Celsius. Okay, now all of you take page number 40. In that Roman letter 6, answer in briefly. First question, define 1 calorie. Okay, this is only the book back question, today's portion. Define 1 calorie. Page number 34. Okay, page number 34. Here in this heading, other units of heat energy, that first paragraph you can mark now. 1 calorie is defined as the amount of heat energy required to rise the temperature of 1 gram of water through 1 degree Celsius. Okay, and this one first question. Okay, brief answer first one. Okay, just mark it, this question. And this question also, this one not book back question, other question, just mark it, define 1 kilocalorie, because only the difference is here 1 gram is there. Here what we have to write, instead of that 1 kilogram. Okay, that is only the different. Next, define temperature, just mark it, define temperature. Temperature is defined as the degree of hotness of a body. Okay, temperature is defined as degree of hotness of a body. And the same page number, here next paragraph, it is a scalar quantity. Mark it, it is a scalar quantity, and this SI unit of temperature is Kelvin. SI unit of temperature is Kelvin. Okay, define temperature. Next, what are the properties of temperature? Property. Okay, first point, property of this temperature, first point, which determines whether the body is in equilibrium or not with the surrounding. That is the first point. Second one, average kinetic energy of this molecule can be mentioned. Okay, temperature rises means kinetic energy of this molecule increases. That is one of the property. And the third one is it is defined that direction of this flow of heat. Okay, temperature defines the direction of the flow of heat. Okay, these are the properties. Okay. Next question, what is the thermodynamic scale of temperature? The page number 32, thermodynamic scale of temperature is defined as the fraction of 1 by 273.16 part of the thermodynamic temperature of the triple point of water. Okay, from here to here mark it. And here these two formulas, relation between Kelvin and Celsius scale, these two formulas just mark it for problems and one word. Okay, Fahrenheit and Kelvin, this is the formula, F plus 460 into 5 by 9. Next question, define thermal equilibrium. Two or more physical system or bodies are said to be in thermal equilibrium. There is no net flow of thermal energy between the system. Next in this same page, page number 33, just you have to mark what is meant by thermal energy. Okay, first we marked what is thermal equilibrium, now mark thermal energy. When a hot object is in contact with another cold object, a form of energy flows from hot object to cold object, which is known as thermal energy. In the same next paragraph, what do you mean by heating? Okay, the process in which heat energy flows from a body at high temperature to another object at low temperature is known as heating. What are the methods of transfer of heat? Conduction, convection and radiation. The heat is a scalar quantity and the SI also mark it joule for one word questions. Next one, cooling. The process of transfer of heat energy, the body at lower temperature is heated while the body at high temperature is cooled. The process of transfer of heat energy is termed as cooling. Next question, what are the characteristic features of heat energy transfer? These 3 points mark it. Heat always flows from system at high temperature to low temperature. Mass of system not altered or not changed when it is heated or cooled. For any exchange of heat, the heat gained by the cold system is equal to heat lost by the hot system. That is, heat gained is equal to heat lost up to this. So today's homework portion, study portion, this 5 questions. Okay, define temperature, thermal equilibrium, thermal energy. What are the characteristics features of heat energy transfer? Define 1 calorie. Okay, this 5 questions. Study thoroughly and write it in that note. Okay. Now all of you take page number 30. Last class we discussed up to this Roman letter 7. Okay. So Roman letter 8 and 9 again we have to do. So Roman letter 8 numerical problems in that first question. Okay. We are going to do now. So take your class note and write this problem. Have you all written this problem? An object is placed at a distance 20 cm from a convex lens of focal length 10 cm. Find the image distance and nature of the image. Find the image distance and nature of the image. First, all of you listen. What is given? First you have to write. Okay. Object placed at a distance of 20 cm from a convex lens. So object distance is given. Okay, 20 cm. Always we have to keep the object to the left side. So object distance we will mention with the letter U. U is equal to minus 20 you have to write. Then focal length. Okay, it is a convex lens. So focal length is positive only. Focal length of this convex lens 10 cm. F is equal to 10 cm. Find the image distance. So V value we have to find. So write the given data first. Object distance U is equal to minus 20 cm. Focal length F is equal to 10 cm. Here why we written this minus? You all know that object is on the left side of this. According to the sign convention we have to write that negative sign. Okay. So always object to be in the left side of this lens. So we have to write this minus. focal length f is equal to 10 centimeter. What we are going to find? Image distance and nature of the image. So to find image distance. Do you know what is the formula for this? What's the formula? Yes. So the formula is 1 by f is equal to 1 by f is equal to 1 by v minus 1 by u. Okay, now we can substitute all these values here. Okay, so 1 by f you have to substitute 1 by, what's the value of f? 10. Okay, 1 by 10 is equal to 1 by v only we want to find. 1 by v minus 1 by u value, what is there? Minus 20. So 1 by 10 equal to 1 by v, this minus into minus plus, so 1 by 20. Now this plus 20 plus 1 by 20, if you are taking this side, it will become minus. Okay, so next line 1 by 10, this plus 120 take this side, minus 1 by 20 equal to 1 by v. Okay, now I want to take this LCM for this 10 and 20. You all know that, isn't it? 10, 20, 5 2s are 10. Here 1 2 is, then 5, 1 5 is 5. So if you are multiplying 5 2s are 10 into 2, 20. Okay, so here LCM 20. Okay, 20. Now if you are take this here, that is 10 into 2. Okay, it's 20, same base. So here also multiply into 2. 1 2 is 2. So here write 2 minus, here already 20 is there, here also 20. So you have to multiply with 1, isn't it? So 1 minus 1 equal to 1 by v. So 2 minus 1, what's that? 1, isn't it? 2 minus 1. So here 1 by 20 equal to 1 by v. So 1 by v is equal to 1 by 20 means what is v? Just to take this reciprocal. So v is equal to what? 20 centimeter. Okay, v is equal to 20 centimeter. So now we got that image distance. Okay, image distance v is equal to 20 centimeter. Okay. So next we are going to find the nature. Okay, nature and the size of the image. See, object is placed 20 centimeter. See here, for a convex lens, focal length 10 centimeter given. Okay, object is placed 20 centimeter. So double to the focal length. So object is at 2f. Okay, so object is placed 20 centimeter. Okay, so here the image formed. Where is the image will be forming? The parallel rays after refraction, it will pass on the principal focus, isn't it? Okay, next a ray passing through the optic center. Okay, optic center, it will meet here. Okay, so the two rays are meeting here. Here only the image is formed. Okay, so this is the real and inverted image. Okay, next you have to write. You no need to draw this diagram. Only have to write the nature of this image is real and inverted. Real and inverted. Nature of the image is real and inverted. Okay, next if you want to find that magnification formula, you know magnification is equal to v by u. Okay, v already we found, what is that? 20, and u is minus 20. Object distance minus 20. If you are cancelling, what will get? Minus 1. Okay, so that only we are getting that inverted image. Okay, the magnification m is equal to minus 1. Nature of this image is real and inverted. Okay, have you all written? Second problem, an object of height 3 cm is placed at 10 cm from a concave lens of focal length 15 cm. Find the size of the image. Height of the object here they given. Height. Okay, size of the object is 3 cm and object distance what they given? 10 cm. It is a concave lens. So concave lens focal length you have to take negative. Convex lens focal length positive. Concave lens focal length is negative. So f is equal to minus 15. And we have to find the size of the image. So size of the image we need to find means First we have to find that image distance, okay, because magnification is equal to image distance by object distance, V by U. So we must find first image distance, okay, then only we can find that size of the image. So we are tried first what is given here, okay. See here, first write that given data, what they given, height of the object, okay, object height h is equal to 3 centimeter. Okay, height of the object what they given 3 centimeter. Next object distance 10 centimeter. Okay, object distance u is equal to minus 10. Minus, you know, it is on the left side. Okay, object placed left side on the lens. Focal length f is equal to minus 15 centimeter. Okay, for a concave lens we have to put the negative sign. Okay, and we have to find the size of the image, that is h dash value you have to find. Okay, so if you want to find that h dash value, first we can find that what is that image distance want to find. Okay, for that we have to use this lens formula. What is the lens formula? 1 by f is equal to 1 by v minus 1 by u. Now you can substitute all this value, f and the u values you have to substitute here. Okay, 1 by f, so 1 by f value what is there? Minus 15 equal to 1 by v minus 1 by, what's that object distance? Minus 10. Okay, so next step, 1 by minus 15 is equal to 1 by v, minus and minus will become plus 1 by 10. Now this plus 1 by 10 take this side, so it will become minus. So 1 by minus 15 plus 1 by 10 take this side, so minus 1 by 10 equal to 1 by v. Okay, and you have to take this LCM for this 15 and 10, so you can write this minus here also, minus 1 by 15 minus 1 by 10. So you have to take this LCM for 15 and 10, what we can get? 15 and 10, 2 5s are 10. Just multiply 5 into 3 into 2. 5 3s are 15 into 2. What's that? 30. Okay, that is the LCM. See here, 30. For to make into same base, you have to multiply into 2. 15 into 2, 30. Similarly here, 1 2 is 2. Here this minus symbol is there, so you have to put minus. Then here 10 into 3. Okay, 10 3s are 30. So here also multiply into 3. Okay, minus 3 equal to 1 by v. Okay, minus 2 minus 5. What's that? Minus 5 divided by 30 equal to 1 by v. Okay, just if you are cancelling, 1 5 is 5. 6 5s are 30. 1 by v is equal to minus 1 by 6. Okay, so v is equal to minus 6 centimeter. Just to take this reciprocal, 1 by v is equal to minus 1 by 6. So v is equal to minus 6 centimeter. We have to find the size of the image. Okay, for that we have to take this formula. Magnification m is equal to, what's the formula? V by u, image distance by object distance. One more formula is there, height of the image by height of the object. Okay, we are going to use this 2. Okay, because here what value they given? The height of the object they given 3 centimeter, h value they given. So you have to use this formula. Okay, so v value already we got minus 6 divided by u. Object distance, what's that object distance? Object distance minus 10 is equal to height of the image. We are going to find height of the object 3 centimeter they given. Okay, so this minus and this minus get cancelled. Okay, just to cross multiply here, 6 3s are 18. Okay, 6 3s are 18 by 10 equal to h dash. So if you are dividing, what will get? 18 by 10 is equal to 1.8 centimeter. Okay, so the height of this image is equal to height of this image h dash is equal to 1.8 centimeter. Okay, this is the size of the image. Okay, size of the image how much? 1.8 centimeter. Next you are going to write Roman letter 9 question number 1. Okay, this one higher order thingy, hot questions. Okay, that first question, while doing an experiment for the determination of focal length of a convex lens, Raja suddenly dropped the lens. While doing the experiment, he dropped that which type of lens? Convex lens. Okay, so he got it got that lens got broken into two halves along the axis. So what's the question is, if he continues his experiment with the same lens, whether he will get the image or not. We have to tell the answer. And is there any change in the focal length? Because the lens is broke into two pieces. So they asked, is there any change in the focal length? Okay. See, if the lens is broken into two pieces also, he can do that experiment with the same lens. Okay. And the image size, same size of the image also only he can get. Okay. Why means only that intensity of this image will be less. If it is broken into two pieces also, the center optic point it is there, the same point. So the intensity of this, the power of this image somewhat it will be faded, like it will be there. The intensity of the image will be less, but he can get the same focal length. Okay. So write the answer. First part, yes, he can get the image of the same size. Take a note and write it. Yes, he can get the image of the same size. Next one. There is second question what they asked, whether there is a change in the focal length. No, there is no change in the focal length of the convex lens. No, there is no change in the focal length of the convex lens, even if it is broken into two halves. Only the intensity of the image obtained will be less. The intensity of the image obtained will be less. Have you all written? Yes. Now the second question, see, the eyes of the nocturnal birds like owl are having a large cornea and a large pupil. How does it help them? You all know that this bird can able to see during that night time also, isn't it? So which will be helping that bird to see that objects. Okay. So here, listen here, write it. Increase in their field of vision and an increased retinal surface help them to collect more ambient light during night. So why the birds can able to see during the night? That field of vision increases due to the retinal surface will be increases. Okay, that nocturnal birds, owls having that retinal surface is more. Okay, increase in retinal surface. So it will be getting to collect that more ambient light. Ambient light means the surrounding light. It can able to be collect clearly. Okay, so increase in their field of vision and increase retinal surface help them to collect more ambient light during night. Have you all written this answer also? Okay, so second chapter completely all the questions over. Okay, so today's portion you mark to questions. Okay, third lesson mark to questions you have to learn. Okay, thank you.